Hi, welcome back to this class, Advanced Artificial Intelligence. This is part six, sorry, and we have earlier five parts already explained about different processes of Transformer Encoder. So I'll take you through the part six, which is here. We're going to explain this part. Um, this part add residual and normalization. Now, in part one, just to recap, in part one, we talked about the whole in brief um, uh, encoder and decoder in brief. In part two, we explained positional encoding and input embedding. In part three, we talked about multi-head attention, and in part four, we talked about add residual and normalization. Uh, and in part five, we talked about feed-forward network. And in this part, which is part six, we will talk about add residual and normalization. Details uh, of this process add and normalization already in part four. So the calculation and everything in part four. Now, remember we had the sentence I like Rojava. So that is the sentence that we had. So this is I, represents I. The X from feed forward. And second row is like, and third row is Rojava. Now, here, this is the input that we have, and that is the output of the feed forward network earlier in the earlier class in part five. So what we are going to do, we will add X plus feed forward neural network output. So that is residual 2, the last residual, X plus feed forward network, which was taking the input X and now adding to the original X before feed forward. So doing that, we have this, uh, uh, we have this row multiplied, element-wise addition. So this plus this plus this plus this plus this, and so on, this plus this. So that's how we are going to do it. And that's done for the first token for I, and for the second token for like is done. So element-wise. Now, that is this helps training, and this help to tackle vanishing gradient, that the problem that is common in backpropagation, and also keeping the original uh, input before the feed forward network. So that's how we do it. And then after that, we will have the first token I mean, this is the first token, okay, which represent I, will be normalized. So normalization will be done by um, summing up all features. Okay, so they are four dimension and divided by four. So, and we will get mu 2.18. Now, each value, each value in the first row will be, we will subtract each value from the mu. And that's how we do it. So each value will So 5.64 minus mu, 1.16 minus mu, 3.43 minus mu. And then we square them, square this and this and this and this. So we square them and we sum them up and we divide by 4. This is the variance. And to get the standard deviation, so square root of the variance, we will get the standard deviation. So that's the standard deviation. Now, the standard deviation, the original uh, the deviation that we have uh, over the standard deviation, we will get the normalization for the first row. Likewise, for what I mean by first row is the first token, first word, which is I in our sentence. For the second token, which is like second token, our token word, we'll do the same. We get the mu, and we get the subtract each value from the mu, and we will square them, and we divide it by number of features, which is 4 in each row, and we get 7.7, and we get standard deviation 2.77. Then divide each value of the deviation by 2.77, and then we get normalized second one. And for third token, same thing. We will get sum of this, and we get the mean, and then the mean minus each one of them, and then square them, and then divide by 4. That's the sum. Divide by 4, and then we get variance. And this variance, we will divide each deviation by the variance so that we can get the normalized value. So here, the final output of the full encoder block, the whole block, is this matrix, 3 by 4. This will be ready to get into decoder, and we will explain decoder with this contribution from encoder so that we can translate I like Rojava into Arabic language. So that's how we're going to do. So now this is done. So the output of this one, we got the output, and we will it will be contributed to the multi-head attention in the decoder block. So that output is done. So far we've done this part. And next we are going to explain all these decoder part by part, step by step, process by process, so that we can get a better understanding. Now I can say that each token now contains contextual information representation. Each token attends itself and attends the other, and has controlled variance. It's ready for the next phase, um, so that we can put it into decoder. So they will be combined with K and V for cross attention in the decoder. So now we can move to the decoder in the next video or next class. So what we have I like Rojava, and we translate it into Arabic, and I like Rojava can be represented by this one. That's the final input. That's the final reading for the encoder. Then we will go to decoder as a writer for this model. So just a small note or a short note on this is a learning purpose for to understand the model. So we will took simplified weight matrix uh, does not represent the actual training everything in the model. So, so the predicted token um, wouldn't be um, uh, wouldn't be actual result. It's a simplified result for learning. And the purpose of this example is to show mechanics and physicality and functionality of output projection and softmax, and not to train and simulate a trained translation model. So we're trying to show this one as a learning example to see the physicality, the functionality, and the mechanism, what happens within encoder, and hopefully we will move to decoder. Um, so if I just go back to recap what we had, so it is this one, transformer encoder, and the last part, which is this one, we've done this part. And yeah, we did the um, residual, which is original input will be added to the feed forward. And then we did the normalization, um, so that we can have a better representation of the input and keeping the original, and also uh, tackling the um, vanishing gradient, the problem that exists in backpropagation, and also um, uh, have a better normalization for training. Uh, Stay tuned. If you have any information or for further information, you can get more information in the links below. Um, Thank you very much and stay tuned. See you next. Uh, See you in the next video. Thank you.